Let's talk about perimeter and area formulas. So many times in algebra, we'll be given word problems to work with that involve working with perimeters and areas. So if you have to stop and go look up the formulas, that's kind of a problem. Most of these formulas are really fairly simple and very much related to each other. So let's just talk about some of the really basic ones. The perimeter of any shape is nothing but the sum of all the sides. So if we have a triangle, of course, has 3 sides. If all the sides are different, the perimeter is going to be A plus B plus C, the length of all 3 sides. If we had an isosceles triangle, remember that an isosceles triangle has 2 sides that are the same. So the perimeter here is going to be 2 times A plus B, but that's still A plus B. If we have an equilateral triangle, this is not perfect, of course, but let's say we had all 3 sides are exactly the same. Well, then, of course, if you know one of the sides and you know they're all the same, then you know the perimeter is just 3 times the length of that one side. What if we had a rectangle and perhaps we want to call 2 of these the length and 2 of these the width? Actually doesn't make any difference as to what we call them. This is how they get that the perimeter of a rectangle is 2 times the length plus 2 times the width, because the length plus the width plus the length plus the width, you just add all the sides, is going to be 2 times the width plus 2 times the length. And of course, those can be in either order. Or if it's a square with all of the sides exactly the same, then if you have 4 sides, they're all the same, and you want to know the sum of all 4 sides, you could just take one side and multiply it by 4. No matter what kind of a shape you have. The perimeter is the sum of all the sides. So if you've got a really weird shape, it doesn't matter. The perimeter is the sum of all the sides, whether there are 3 or whether there's 15. Area is a little different. The area is the amount of space inside. In other words, not how much it took to build the walls, how much carpet it's going to take. So the area of a rectangle, again, we could call this length and width, and again, it doesn't really matter. The area of a rectangle is going to be the length times the width, or the product of the 2 perpendicular sides. If it's a square, so that the length and the width are exactly the same, so the area of a square would be the length times the width. And in this case, I called them both S. I could have called them A or Z or Q or whatever. It's just going to be whatever the length of the side is times the length of the side. And since the 2 lengths are the same, it's going to be S squared. What if we have a parallelogram? Now with a parallelogram, pretend like I drew this a little better. The 2 opposite sides are parallel. Well, with a parallelogram, if I were to cut this down from this vertex straight down at 90 degrees to the other side, and then turn around and take this and move it over to here, it would become a rectangle because these 2 sides are parallel. This triangle has to be exactly the same size as this triangle. And since once we make a rectangle out of it, the area would be length times width, but this side would be taking it the place of the width, and they typically call it the height now. So this is the height, this is the length. So the area of a parallelogram is the height, let me write it out, is the height times, they tend to call the other side the base. It's simply the perpendicular distance between two of the parallel sides. So you could measure it over here if you want. It's same as this one, it's same as this one. So if you let this be the height, and then the side perpendicular to that we call the base, then it's just going to be one of the sides times the perpendicular distance to the other side. So the shortest distance between the sides. You can always take any parallelogram and make a rectangle out of it just by cutting it down from one vertex straight down and then moving that to the other end. If we have a trapezoid where two of the sides are parallel, they tend to call this base 1, and then the other side that's parallel to that, two of the sides are going to be parallel. So the two parallel sides, if we call those the bases, base 1 and base 2. And the distance between them, the shortest distance is going to be perpendicular. We call that the height. It turns out that even if this is not the same angle here, so that you could just easily see that you could take this and flip it over and make a rectangle out of it, it's not necessary to do that. What we do is the area of this is going to turn out to be the height, the distance between the parallel sides, times the average of the bases. You get the average length here, split the difference. And I'm not going to go into as much of a proof of that. You can kind of see it if these two angles, if these were the same angle and these were the same angle, then this triangle would fit very neatly over here and make a rectangle out of it. But without going into more complicated proof to take care of a situation where they're different angles, let me just say that it's the height times the average of the bases. Well, if you take these two, base 1 and base 2, and get their average, then you would be taking them, adding them together and dividing by 2. So they typically write this as 1/2 times the height times the sum of the bases. But if you're going to just learn it, it's much easier to remember that you get the average of the two bases and then you multiply that by the distance between. If we took a rectangle and drew a diagonal across that, then you can see that the area of one of these triangles is going to be exactly half of the area of the rectangle. So if this is length and width, and the area of the rectangle is length times width, then the area of the triangle is half of that. So 1/2 the length times the width. If we look at a parallelogram, Again, you can see that one of these triangles is half the area of the parallelogram. So the area of the parallelogram is, if this is the height and this is the base, is the height times the base. So the area of the triangle I drew in would be 1/2 times the height times the base. Well, if I took just a triangle, you can actually always make a parallelogram by taking a triangle and then copying it over here. And that would make a parallelogram out of it. So if this is the height, and if provided this one is the base, this would be the height. In a triangle, the height is the perpendicular, in other words, 90-degree angle, the perpendicular distance between any side and the other vertex, the vertex that's not on that side. And because if you double that, it's going to make a parallelogram, then the area of any triangle is going to be 1/2 the height times the base. 1/2 the product of the height and the base. And this will work for any triangle. That's why to get the area of a triangle, we have to remember to always multiply by 1/2. And I think that's the part that most of us have a tendency to forget. So these are very, very basic areas and perimeters. With a circle, all circles have exactly the same shape, right? Because, you know, it's a circle. So instead of the perimeter of a circle, we call the perimeter of a circle the circumference, and it's related to how big a circle it is. So it's always a ratio of the radius. So the circumference of a circle is always going to be 2 pi r, 2 times pi times whatever the radius is. Only the radius is going to make a difference. You can either leave pi as pi, or if they're going to get a numerical estimate, they'll typically use 3.14 as the estimate for pi. The area of a circle is pi r squared. Notice that it's still got a 2 and a pi and r, but with area, the radius is squared. The 2 moves up here. So it's actually pi times the radius instead of pi times the radius just times 2. If we have a shape that involves different shapes, for instance, if we take a little house here and we want to find the area of this house, the area of the house is going to be the area of the square plus the area of that triangle. If we had, sometimes they'll give us a box with maybe a semicircle on each side. Now they have to say it's a semicircle, but perhaps we have a track here so that this distance would be the radius. This distance is, of course, 2 times the radius. So we can find the perimeter and we can find the area of this if we know just the radius and this distance right here. The perimeter of this, these two semicircles, if they state, we can't assume, if they state that at each end we have a semicircle, half of a circle, and this is a rectangle, then these two distances have to be the same. So these two make up one circle. So the perimeter would be the circumference of the circle, 2 pi r, plus this length twice. So we can make up our own formula. The area would be the area of the circle plus the area of the rectangle. The area of the circle is going to be pi r squared. Remember, they have to give us r. The area of the rectangle, because the length here is going to be 2r. And then we've got this. The area of this would be 2 times r times the length, which is the same thing as length times width. So sometimes the shape is a combination of other shapes, and we have to make up our own little formula there.